We're using the Level 7 Part 1 practice test, which is in your workbook and starting on page 201. We're using this as a review for a retake for Level 7 sections 1 and 2. So if you want to retake that test, this is your retake assignment. So in the first section here, they're just asking us to find the exact value, which means we're not looking at a calculator, we're going to look at the unit circle. So this is saying sine of what angle is -1? And I want to know what angle has a sine of -1. So I'm going to bring in the unit circle. -1 would be the y coordinate. And if I look, remember the domain for the inverse of sine is in quadrants 1 and quadrant 4. So here I'm looking at 3 pi over 2 as the angle that has a sine of -1, but 3 pi over 2 is not in our domain of pi over 2 to negative pi over 2. So we're actually going to use 3 pi over 4, but that has the same value as negative pi over 2. Okay, so if we're looking at in quadrant 4, those are going to be negative angles between pi over 2 and 0. And in quadrant 1, they're going to be positive angles between 0 and pi over 2. All right, so this theta is actually negative pi over 2. All right, tangent works the same way. The domain of the inverse tangent is in quadrants 1 and 4, and I want the tangent value to be 0. So if you remember, I have tangent is sine over cosine, and I want sine to be 0 and cosine to be anything else. So if I'm actually looking for the angle that's going to give me sine equal to 0. And if I look here, sine equals 0 at 0 degrees, which is between pi over 2 and negative pi over 2. So the angle that gives me sine of 0, because 0 divided by anything is 0, is 0. And the last one is an inverse cosine, and our value is negative square root of 3 over 2. Cosine has a different domain. It's in quadrants 1 and 2. So I'm looking in quadrants 1 and 2, just the top half of this, but the first value has to be negative square root of 3 over 2, and that would be the angle 5 pi over 6. So this angle is 5 pi over 6. Number 4, using a calculator. I'm going to use a calculator. You can use decimals if you want, but I'm looking for sine of what angle is 0.1. First thing I want to make sure is that my mode is in degrees, because it asks us to find this in degrees. So if you're using decimals, you can make sure it's in degrees with the wrench in the top right corner. But this is in degrees. And I'm just going to do inverse sine. Okay, and on a calculator it would be the second button and then the sine function, because right above sine it says inverse sine, and I'm just going to type in 0.1. And that angle is 5.739, which is 5.74. 2 decimal places. Some of you need to make sure that you're rounding accurately. So this is 5.74. Inverse tangent of 5 would be 78.69 degrees, and inverse cosine of 1 divided by 8. Okay, so you can do this on Desmos as well. If I do inverse cosine, just type in 1 divided by 8 in the parentheses, and that would be 82.82 degrees. All right, so number 7 says to find the exact value of each, and with this, the exact value says don't use the calculator. So I'm looking first, I'm going to work on the inside, for the value or the value of cosine of 7 pi over 6. So I'm going to find that angle, and I'm going to find 7 pi over 6. And the cosine of that is going to be negative square root of 3 over 2. So that inside part here is negative square root of 3 over 2. Now I want the inverse cosine of that angle. And if 7 pi over 6 were in the domain, and for cosine it would be in the quadrants 1 and 2, if 7.6 or 7 pi divided by 6 were in these two quadrants, we could just cancel them out. But 7 pi over 6 was not in the domain of cosine. So to find this angle, I'm going to look in quadrants 1 and 2 for the angle that has cosine of negative square root of 3 over 2. Okay, so originally it was here. But if I look up here, negative square root of 3 over 2, the angle that's in the domain is going to be 5 pi over 6, which is just the reflection here of 7 pi over 6 over the x-axis. So 5 pi over 6 is the angle that's in the domain. Number 8. Sine of negative 3 pi over 7. Now this one I don't have exactly on my unit circle, but if I were to kind of determine where this is, so 3 pi over 7 is close to what am I thinking here? It's close to pi over 2, but not quite. But it's in this quadrant, which is in the domain. So this angle actually is in quadrant 4. And because it's in the domain of the inverse, I can cancel these, and negative 3 pi over 7 is my solution. Number 9. I have sine of inverse sine of 1/4. So again, I'm going to look to see where would 1/4 be on my unit circle. And 1/4 is not on my unit circle, but it would be somewhere in here. All right, which is in quadrant 1. So this is in quadrant 1, and the sine of an angle in quadrant 1 is going to be the same as the inverse sine. So these are going to cancel out, only because 1/4 is in my domain. And actually my domain, negative pi over 2 to pi over 2. And 1/4 is between that, so these are going to cancel, and I get 1/4. Now I'm looking for the inverse cosine of 1.2. Now cosine has to be between 0 and 1. And 1.2 is greater than that. So this is not in my domain. So there's no solution. And the domain for tangent is all real numbers. So it doesn't matter what I'm finding with inverse tangent. If I do a tangent and inverse tangent, they cancel, and I'm left with 2. Number 12 says find the inverse. So first thing we do, we have it in the form of y equals. I'm going to switch x and y. So x equals -2 cosine 3y. And now I'm going to solve this for y. So I'm going to divide by -2. So x divided by -2 is cosine of 3y. Now to undo the cosine, I'm going to do inverse cosine of both sides. So inverse cosine, and the angle that I want the cosine of, I want x divided by -2 or -x halves, and that equals 3y. And in this case, to solve for y, I'm going to divide all of this by 3. So this is going to give me an angle, and whatever that angle is, I'm dividing by 3. So it looks like cosine -1, -x divided by 2, and all of this is divided by 3. Okay, so this is the inverse equation. Number 13, I have to find the inverse again. So I'm going to replace x and y. So I'll say x equals 4 sine of y minus 1, and then plus 2. I want to solve for y. So first thing I have to do is undo this plus 2. So I'm going to minus 2. And in the same step, I'm going to also divide this by 4. So I subtracted 2. Now I'm going to divide all of this by 4. And that's going to equal sine of y minus 1. To undo the sign, I'm going to do inverse sine of all of this. So I have x minus 2 over 4, and that equals y minus 1. And to solve for y, I'm just going to add 1 to this. So inverse sine of x minus 2 over 4 plus 1 is equal to y. Number 14, find the exact value. So we are going to be going back to our unit circle. Working on the inside, I'm looking for the angle that has cosine equal to negative square root of 3 over 2. So again, cosine is in quadrants 1 and 2, and I want negative square root of 3 over 2. So that would be this angle right here. Oops. In quadrants 1 and 2, that would be this angle right here. So this is 5 pi over 6 has a cosine of negative square root of 3 over 2. So my angle is 5 pi over 6. And now I want to find the tangent of that angle. All right, so remember tangent is sine over cosine. So I'm going to look at 5 pi over 6. Sine is 1/2 over negative square root of 3 over 2. So I have 1/2 divided by negative square root of 3 over 2. And here I can multiply this by 2 on top and bottom, and those cancel out. Okay, or I can multiply by the reciprocal and the 2's will cancel. Nonetheless, I have left 1 over negative square root of 3. And if I rationalize the denominator, I'm going to multiply the top and the bottom by the square root of 3. On top, I get square root of 3. And on bottom, I get 3. And I have a negative here. Usually I put the negative on the top. Number 15 is cosecant of inverse tangent of 1. Now I'm looking for an angle in quadrants 1 or 4 that have a tangent of 1. That means the sine and the cosine have to be the same. And in quadrant 1, sine and cosine are the same at pi over 4. So inverse tangent of 1 is pi over 4. And then I want to find the cosecant of pi over 4. All right, well, this is the same as 1 over sine of pi over 4. And sine of pi over 4 is 1 over, sine of pi over 4 is square root of 2 over 2. And when I multiply by the reciprocal, this is like saying 1 over 1. Multiply by the reciprocal, this is going to be 2 over square root of 2. Now I need to rationalize the denominator. So I'm going to multiply top and bottom by square root of 2. This gives me 2 square root of 2, and then on the bottom I get 2, and these cancel. So that's just square root of 2. So for number 16, we are looking for exact values still. And first, I'm looking for the angle in quadrants 1 or 4, that's my domain, that has a tangent of negative square root of 3. Now, if I think about what I have here, remember tangent is sine over cosine, and I want negative square root of 3 as my answer. So in quadrant sine of negative square root of 3 over 2 would be 5 pi over 3. So let's just see what happens if when I do sine over cosine. Negative square root of 3 over 2 divided by 1/2, which would be multiply the top by 2, which is negative square root of 3. All right, so that's the angle that I'm looking for. So this angle right here is 5 pi over 3. Now 5 pi over 3 is in the quadrant, but it's not in my domain of between negative pi over 2 and pi over 2. So I have to think of this angle as a negative angle, and this actually is negative 1/3. If I can think about this as, I'm going to write this over here on the side, 6 pi over 3 is what I would have here, minus 5 pi over 3, which gives me, in the negative direction, pi over 3. So this angle is negative pi over 3. Negative pi over 3. And I'm just double checking my work here. Now I want the sine of that angle. All right, and the sine of this angle, going back to that negative pi over 3, sine is negative square root of 3 over 2. All right, number 17. I'm looking for cosine of 3 pi over 4. So this is just the measure of cosine. And then I'm going to look to see what angle has the same sine. So cosine of 3 pi over 4, 3 pi over 4 is right here. cosine is negative square root of 2 over 2. So cosine 3 pi over 4, negative square root of 2 over 2. And then I want to know what the angle is that has the sign of the same number. Now remember, this is in quadrant 2, and my angle has to be in quadrants 1 or 4. So in quadrants 1 or 4, I'm looking for negative square root of 2 over 2, which is this angle right here. Negative square root of 2 over 2 is my sine, and this would be negative pi over 4. Okay, because it's going down in the negative direction. So my angle is negative pi over 4. Number 18, I want the inverse cotangent of square root of 3. Now, cotangent I'm going to think of in terms of cosine over sine. And I know I want a square root of 3 here. So if I look for the cosine value, and that's a positive value, so it's going to be in quadrant 1, that has a square root of 3, for cosine, it would be pi over 6. All right, but I'm looking for the cotangent. So this is square root of 3 over 2 divided by sine is 1/2. And if I multiply by the reciprocal, I'm going to get square root of 3. So the angle I was looking at is pi over 6. All right, so I was just checking here to make sure that cosine divided by sine was square root of 3, and that angle with cosine divided by sine was pi over 6. Number 19, I have cosecant of negative 2. Now cosecant is 1 over sine, 1 over inverse sine, and that is of negative 2 over 1. So I want to know what angle has a sine of, if I flip this over, sine of the angle is negative 1/2. All right, so I just did the reciprocal of both of these. So what angle has a sine of negative 1/2? Okay, and I'm looking at the y-coordinate. Negative 1/2 is here, which is a negative angle, and that's negative pi over 6. 12 pi over 6 minus pi over 6 minus pi over 6 is 11 pi over 6. So it's the negative angle that we want here. Number 20. In this section, just like we did on the first page, we're doing the inverse secant. We still want our answer in degrees, so we probably will still have our decimals in the degree mode. And I can just type in inverse secant, negative 3 divided by 2, and that would give me 131.81 degrees, 26.57 degrees, and 11.54 degrees. Okay, so just practice typing those in. Make sure that those are the measures that you get. And then for 23, it's asking me to solve the following. So I want to find out what x is. So I have to undo everything that's happening to x. So my first step would be divide by 3. So inverse sine of x is pi over 3. And if I now, on both sides, do sine, the sine and the inverse are going to cancel, and I'm left with x equals sine pi over 3. And we know that sine of pi over 3, I can look on my unit circle or I can look on the hand. Pi over 3 is, this is pi over 6, pi over 4, this is pi over 3. So sine would be square root of 3 over 2. Next one, solving for x. I'm going to divide both sides by 2. So inverse cosine of 3x is negative pi over 2. Now I want to undo the inverse cosine to get 3x by itself. So I'm going to cosine both sides. They'll cancel here. So I'll have 3x is cosine negative pi over 2, and then I'm going to divide by 3. All right, so I'm able to find this value. Negative pi over 2 is here. Cosine is 0, so I have 0, oops, go down here, divided by 3, which is 0. And the last one. First, I'm going to divide by 4. So inverse tangent of 2x equals pi over 4. I'm going to undo the inverse tangent, so I'm going to tangent both sides. So these will cancel. I have 2x is tangent pi over 4, and then x is tangent pi over 4, and then divide that by 2. Well, I can do tangent of pi over 4. Okay, looking at pi over 4, tangent would be sine over cosine. Those are the same values, so tangent of pi over 4 is 1. So this is going to be 1 over 2. All right, so this is good practice for your retake test over sections 7.1 and 7.2. And hopefully you have a lot of good practice and you're ready to do a better job.